Okay, picture this. There's literally only one natural disaster capable of ending absolutely everything on our planet in a single day. And no, this isn't some Hollywood science fiction. It's a deeply embedded, incredibly violent part of Earth's history. So let's dive into this explainer and look at exactly what happens when the universe decides to just throw rocks at us. We've all seen the blockbuster movies, right? The giant tidal waves, the massive fireballs. But the actual physics of a space rock hitting Earth is way more bizarre and honestly, way more devastating than anything you've seen on a screen. But to really wrap our heads around this monster of an event, we actually have to start on a seemingly completely ordinary morning.
Let's drop straight into February 2013. People in Chelyabinsk, Russia are just commuting to work, sipping their morning coffee when suddenly, boom, the sky literally erupts. A rock roughly the size of a house, ripping through the atmosphere at 19 kilometers per second, detonates absolutely out of nowhere. We really only know what this looked like because thousands of Russian dashcams managed to capture this blinding, terrifying flash.
Now, here is the truly terrifying math. This thing was just a minor piece of cosmic debris, right? A tiny speck. Yet, it ended up damaging 6 entire cities, rocking up a billion rubble repair bill and injuring over 1,500 people on the ground. So, you might be wondering, how on earth does a rock that small do so much damage, especially when it didn't even leave a crater? Well, the trick is, it didn't strike the ground like a missile. It actually detonated right in midair. It all comes down to a classic battle of physics, the speed of light versus the speed of sound. Human instinct totally took over, drawing people straight to their windows to look at that incredible blinding flash. But the shockwave? That was moving a lot slower. It took a full 83 seconds for the blast to travel from the explosion all the way down to the streets, blowing the glass right into the faces of the people who were just standing there watching. But you know what the most terrifying part of this entire event really is? We were completely blind to it. Completely. See, ground-based telescopes look for sunlight reflecting off asteroids. But because this specific rock snuck up on us from the exact direction of the sun's glare, not a single early warning system on the entire planet saw it coming until the sky lit up.
Wow, right? But Chelyabinsk was just a cosmic warning shot. To see what a larger rock can really do, we have to dig into this intense historical mystery, one that the world actually amazingly ignored for nearly 2 decades. Back in 1908, something massive exploded over a remote Siberian forest. The flash was so incredibly bright, people literally felt the heat on their faces from 60 kilometers away. It flattened an area the size of a major modern city. But here is the truly chilling what-if scenario. If that exact same rock had shown up just 5 hours earlier, the Earth's rotation would have placed St. Petersburg directly in its crosshairs, which could have killed hundreds of thousands of people. But because it hit an empty, uninhabited forest, the world basically just shrugged and barely noticed. So when a Russian geologist finally bothered to trek out to the site 19 years later, he found this completely bizarre anomaly. The blast wave had hit the forest floor straight down, completely vertically. Millions of flattened trees were pointing outward like spokes on a giant bicycle wheel, but right at the epicenter, a cluster of dead, scorched tree trunks was left standing perfectly upright. It's like something out of a sci-fi movie. Now this right here is the extreme physics of what we call an airburst. To put this into perspective, these space rocks are traveling up to 20 times faster than the fastest artillery shells ever fired by humans. When they slam into our upper atmosphere, they compress the air so violently it creates this superheated wall of plasma. The poor asteroid, which is actually pretty fragile, literally can't handle the intense pressure and just vaporizes in a cataclysmic mid-air explosion. Sure, an airburst will absolutely flatten a sprawling city, but a true ground impact, like from a much larger, denser, maybe metallic asteroid, that brings an entirely different level of cataclysmic energy. It doesn't just flatten the surface, it basically excavates the Earth, violently throws molten crust into space, and completely rewrites the geology of the entire planet. Which brings us to the ultimate monster of our planet's history. 66 million years ago, a rock wider than Mount Everest is tall came screaming in and slammed right into the shallow sea of the Yucatan Peninsula. Try to wrap your head around this. The energy released was equivalent to every single nuclear weapon ever built by humanity, multiplied 10,000 times over. Just boom. So this wasn't just some big explosion, it was a cascading, multi-layered apocalypse. As we mentioned, this is the only natural disaster capable of literally changing habitability across the entire globe in just one day. First came the instant vaporization, then came the towering megatsunamis, and then, if you can believe it, the sky itself essentially turned into a giant oven. Actually, scratch the idea that the blast just wiped out the dinosaurs everywhere all at once. It was way worse. Trillions of tons of molten rock were ejected into space, and as it rained back down through the atmosphere, it acted like a giant broiler, igniting global wildfires everywhere. And then, the soot and vaporized sulfur choked out the sky, plunging the world into a dark, freezing, sunless impact winter that lasted for years. Starvation is what really finished the job.
But here is where it gets crazy. This absolute catastrophe was actually a massive cosmic reset. It totally cleared the ecological stage. Small burrowing mammals, who happened to be our distant ancestors, managed to survive because they were hiding underground and didn't need tons of fresh plants to eat. So in this weird, beautiful twist of cosmic irony, we literally owe our entire existence as a species to the absolute worst day in Earth's history.
Okay, so to understand our actual risk today, we have to get rid of this idea that space is just empty. It's really not. The solar system is basically a giant cosmic conveyor belt of hazardous leftover rubble, constantly getting nudged around by the gravitational pull of giant planets like Jupiter. The threat of an asteroid impact isn't just ancient history, it's a permanent, ongoing feature of our cosmic neighborhood.
And honestly, what's even wilder is something called the Yarkowski effect. Get this. Simply absorbing sunlight and radiating heat can act as a microscopic, slow-motion cosmic engine. As an asteroid spins, the side radiating heat back into space gets this tiny, almost imperceptible little push. But over hundreds of thousands or millions of years, that microscopic thrust can steer a totally harmless rock right into an Earth-crossing path. Insane, right?
For most of human history, we were just blissfully oblivious. I mean, think about it. We went from literally ignoring a city-destroying blast in 1908 to getting caught completely by surprise and having our windows blown out in 2013, to finally fighting back. That's right, we are now actively figuring out how to alter the mechanics of the solar system. Enter 2022, when the DART mission delivered an absolute masterclass in audacity. We literally flew an autonomous spacecraft, which, by the way, was roughly the size of a standard vending machine, millions of miles, just to purposefully punch a space rock named Dimorphos. Moving at a blistering 6 kilometers per second, this little craft slammed into the asteroid to see if we could change its path. We successfully played a game of high-stakes cosmic billiards. Mission planners were just hoping to maybe change the rock's orbit by, 10 minutes. But instead, that incredible impact shortened the orbital period of Dimorphos by a massive 32 minutes. We actually proved that a kinetic deflector shield, crashing something into a rock to push it away, really works. Now let's look at the reality of today. We've pretty much mapped out the massive dinosaur-ending threats, which is great news. But the smaller city-killer rocks, they're still out there, lurking in the dark, often hiding right in the sun's glare, just like that Chelyabinsk rock did. To close this planetary defense gap, we desperately need new tools, like the planned NEO's Surveyor Space Telescope, which will hunt for the actual heat signatures of these hidden rocks, instead of just relying on reflected sunlight. And guess what? We are about to get a spectacular, real-life demonstration of our orbital math very soon. On Friday, April 13th, 2029, a massive 340-meter asteroid named Apophis is going to fly safely past Earth. But here's the kicker. It's going to pass closer to us than our own geostationary weather satellites. It's going to be a naked-eye event, flying so insanely close that Earth's gravity will physically bend the asteroid's orbit as it passes by. How cool is that? So, what does this all mean for us? Well, unlike the dinosaurs, who were just completely helpless victims of a brutal cosmos, we are literally the first species in Earth's entire 4.5 billion-year history capable of preventing our own extinction. I mean, the dinosaurs couldn't do orbital math, they couldn't build rockets, but we can. We are no longer just passive passengers on this planet. With constant vigilance in science, we actually have the power to ensure the sky never falls on us again. The big question is no longer whether we can stop the next asteroid, we've proven we can, but whether we'll have the foresight and the funding to actually see it coming in time. So, are we going to keep our eyes on the stars, or are we going to let the universe catch us by surprise?